In our fourth unit, as we are attempting to prove that triangles are congruent, we started in lesson 1 by just showing that polygons are congruent and trying to understand what that means for us. If polygons are congruent, then their corresponding parts are congruent. If the corresponding parts of polygons are congruent, then we know that the polygons are congruent to each other. And then when we proved pairs of triangles congruent, we noted that showing all of their corresponding parts congruent proved to be a lot of work. And if I know you and if you know me, then we know that we don't like to do a lot of work, right? Let's figure out the shortest way possible to get it done well so that we are still having the same learning experience, still doing the right amount of work. But is there a way that we can expedite the whole process? And lucky for us, there is. When we are showing triangles congruent, there are a few shortcuts that we can use. There's actually 5, and we're going to learn about 2 of them in this quick lesson right here with side, 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 and side, angle, side, SSS and SAS. This means that we have 3 pairs of corresponding sides congruent. This means that we have 2 pairs of corresponding sides congruent and the angle that is formed between those 2 sides. All right, congruent as well. If that happens, then we've got these special magical triangle congruence shortcuts. So instead of having 3 pairs of sides and 3 pairs of angles, we can just, instead of having 6 things, we can have just 3 things. All right, but it has to be the right 3 things, and that's what we're going to chat about today. So our goal is to prove that triangles are congruent using these 2 postulates, all right, these 2 postulates, these shortcuts that we get to apply in this particular lesson. So if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent to each other. All right? The converse of this is obviously true, but we aren't concerned with that. If we know that the triangles are congruent, then we know that all of their sides are congruent and all of their angles. Here, this says if we know that all 3 sides, pairs of corresponding sides are congruent, then we don't have to worry about the angles at all, because there's only one way to make a triangle that has these 3 side lengths, all right? And whatever that case would be, it would end up having pairs and pairs and pairs of congruent triangles, all right? So we would apply this in this situation. Here is a triangle AXY, and we are told a few things. We are told that M is the midpoint of the base of this triangle, which in this particular picture is XY. So M is the midpoint of XY, which means that I can draw the segment MA or AM in such a way that it now shows us that we have 2 triangles. So we had one triangle, we identified the midpoint of one of the sides, we made 2 triangles, yay. Now this triangle is extra special. We know that AX and AY are congruent to each other. That's important information. That means that this is an isosceles triangle. That means that this is an isosceles triangle. And we are going to prove today that these 2 triangles, AXM and AYM, are congruent to one another. So what we want to make sure that we understand is if we're saying that these triangles are congruent, then we need to know at least these special 3 things for side, side, side. 3 pairs of corresponding sides congruent. Or we need all the 3 sides and all the 3 angles. Well, getting all the 3 angles is going to be a little bit tricky here. I don't know the measures of these angles or those angles or these angles. You may know from previous experience that in an isosceles triangle, the base angles are congruent to one another. You may know that already. We're going to talk about that in a few lessons. But we're going to try to use a shortcut here. So I'm going to show that these sides are congruent to each other, that these sides are congruent to one another. And then finally, I've got this side congruent to itself. So remember that when we're saying that a segment is congruent to itself, that's a particular property. So that's our goal, that's our plan. How can we do that given this information? Well, hopefully you recognize that if M is the midpoint, then it cuts this segment into 2 congruent parts by the definition of midpoint. Likewise, if you know that this segment is itself, then you know that it's congruent to itself because of the reflexive property of congruence. So we're going to make each of those statements here in this proof. If you want to pause the video and try to do it yourself, go for it. But here goes. I'm going to show that these triangles are congruent by stating what's given to me, that segment AX is congruent to segment AY. All right? Segment AX and segment AY are congruent. That's given information. Thank you for giving me that information. Next, I'm going to recite the information that is M is the midpoint of segment XY. That is also given information. We don't always have to put the givens first, but sometimes it is useful. I'm going to start with that pair of sides then I'm going to this pair of sides here. I'm going to use the fact that m is the midpoint to say that xm is congruent to ym. That's the definition of midpoint. The definition of midpoint says that point M cuts that segment into two congruent parts. And then finally, MA is congruent to itself. The reason there is reflexive POC, which means that these triangles, again, they give us the congruent statement so we know what our corresponding parts ought to be. Our congruent statement is what we're supposed to prove. Our very last statement is what we're supposed to write down here. AXM, triangle AXM is congruent to triangle AYM, and the reason here is the side, side, side postulate. We're just going to abbreviate that as SSS. It's a lot easier than writing side, side, side and the word postulate. You don't have to write the word postulate on there or even abbreviate it. It just write down SSS, and that is your reason. We showed that we had three pairs of sides, S, S, and S, so I know that I'm going to use side, side, side. All right? It's always good to kind of keep track. Do I have pairs of sides congruent, pairs of angles congruent, etc.? All right, how'd you do on that? There's another shortcut called the side angle side postulate. The side angle side postulate says if you've got two pairs of sides and the included angle in one triangle if you've got two sides in the included angle in one triangle congruent to two sides in the included angle in another triangle, then those triangles are congruent. So that we got to understand what is this included angle. So two sides in the included angle of one triangle, if they're congruent to two sides in the included angle in another triangle, then those two triangles are congruent. So what I mean by that is, let's think about what this included angle is. In this picture, I am marked with side JH. I've got side JH. I've got side JK. You should notice that there is a shared letter. All right, these two sides form their included angle. Angle J is the included angle between side JH and side JK. Over here, I guess I already have that on there. Angle J is included between sides JH and JK. Hopefully that is evident by the picture, that we can tell that this angle is included between those sides. But we also have this situation over here. Obviously a different triangle, not saying that these two triangles are congruent. But here I've got triangle CDE. I've got this segment marked, I've got this segment marked. And what is the angle that's included between segment DE and segment CE? Well, it's going to be the angle at E. All right? Hopefully you can recognize that the angle that's included between those two sides is the angle that shares a letter with each of those two sides. All right? So you can know that if I were to not even give you the picture and say, which angle is included between segment EC and segment ED, you would note that they both have a capital E. So it would be the angle at E, which you could name DEC if you wanted to, or CED if you needed to. Right? Otherwise, we can call it angle E in this particular situation. So again, we don't need the picture, but the picture is helpful. So what we want to be able to do is maybe construct a proof that says, hey, I've got these two pairs of sides congruent, I've got these two pairs of angles, or this one pair of angles congruent, and this angle is included between those two pairs of congruent sides. So that means that I've got these triangles congruent. But sometimes we are on the hunt for that information. Sometimes it's not just, hey, this is given, hey, this is given, hey, this is given. Sometimes it's there, but it's like, hey, M is the midpoint of this segment, and so you have to know what midpoint means so that you know that you have a pair of congruent segments. Or, hey, these segments are perpendicular. Oh, that means that those angles are right angles. Hey, those right angles are congruent. Maybe it's information like, hey, these lines are parallel. All right? And so if these lines are parallel, then we should know that we've got corresponding angles congruent, or we've got alternate interior angles congruent. That's information that when they give us that, or they tell us that, we need to put that to work immediately. And think about how we can use those statements to say that I've got a pair of congruent angles or a pair of congruent sides. All right? Determine what additional piece of information is needed to prove the triangles are congruent using SSS or SAS. So here I have a few pictures. All right, on this first one here, we're going to note that I've been given that these segments are congruent to each other. That's awesome. But I can also use my brain to understand that I've got a reflexive segment congruent to itself. SK is congruent to KS. So then, what else do I need? If I want to use SSS, I would need to know that I've got a third pair of sides congruent. I would need to know, I need that RK is congruent to TS. I would need to know that RK is congruent to TS. If I wanted to use side angle side, I would need to have the included angles. I would need to have this angle congruent to that angle, because these angles are included between those two pairs of corresponding sides. So if I wanted to use SAS, I could use two pieces of information. One of two pieces of information. I would need either to know that the angle at S and the angle at K were congruent, but I need to use three letters there. I need to say angle RSK, congruent to angle TKS. Or I could be fancy. And instead of saying directly, hey, if I know that those angles are congruent, that's great. That's obviously the easy answer. But there's another way to show that those angles would be congruent, and that's if these segments were parallel. If these segments were parallel to one another, then that means that the alternate interior angles then would also be congruent. So sometimes the information is given to you directly, but it is something that feels a little awkward. It's like, why are they telling us that those lines are parallel? I don't need parallel lines, I need congruent segments, or I need congruent angles. So if they ever tell you parallel, we know from Unit 3, I need to make sure that I am identifying which angles are going to be congruent if I know that those lines are parallel. Over here, I don't have any information here, all right? All that I know right here is that I've got this segment congruent to itself. Now, there may be some other things, like if they told us that XW is congruent to WZ, that'd be great. If I knew that this segment was congruent to that segment, that would be great, all right? But unless they tell us that, I don't know. This would have to be, I need two pieces of information. I need to know that these were congruent, and I need to know that those included angles were congruent. Or, if they tell us this, then I would need to know also that these angles were congruent to each other. So that I can have SAS. So depending on what you're trying to do, you're going to train your eyes to look for that information. All right? There's not really much that we can do with that one. I need two pieces of information, not just one. For this last item, this one's a little bit hard to visualize. But if I wanted to show that this triangle was congruent to this triangle, oh, that marker's dead, to this triangle, I have a pair of congruent sides already, and I have a reflexive side congruent. I would just need BD for SSS. I would need that BD is congruent to AC. That would give me SSS. Or if I'm going to use SAS, I would need to know that this big angle at D is congruent to this big angle at C. And let's name those angles. Angle ADC congruent to angle BCD. All right, if I have that this big angle in this red triangle is congruent to this big angle in this blue triangle, then I would have two sides, two pairs of congruent sides, and the included angle at the big angle D and the big angle C. So the job there is to hunt for the information that you need to make the proof. All right, let's do this last one. You're going to see this picture quite a bit over the next few weeks. Given that line segment FG is parallel to line segment KL, it's marked in the picture, you can't see it very well, but there's my little triangle saying that, hey, these are parallel. Parallel lines, immediately. Corresponding angles congruent, alternate interior angles congruent. Look for those. And then we're also told that FG and KL, they're not only parallel, but they're also congruent to each other. Yay. Now, we know that by the alternate interior angles theorem, these two angles are congruent. Here's what we do not know. Please pay attention here. We do not know that these two angles are congruent yet. These lines were not told that they're parallel, so the alternate interior angles, we do not know if they are congruent yet. Now it turns out that they are congruent angles because the triangles are congruent. And therefore, if these alternate interior angles are congruent, then yeah, these lines are parallel by the converse of the alternate interior angles theorem. But we're not there yet. What we do know is that this is congruent given. These are parallel given. These angles are congruent by the alternate interior angles theorem, and then this segment is congruent to itself by the reflexive POC. See if you can write out that proof. Again, given congruent side, first statement, given parallel sides, second statement. Congruent angles by the alternate interior angles theorem, third statement. Segment congruent to itself by reflexive POC, fourth statement. The triangles are congruent. Fifth statement. Number 1. FG is congruent to KL because they told us that's a pair of sides. I'm going to do side, then angle, and then side. All right, that's my goal. Side, angle, side. FG is parallel to KL because they told us. So now the angles at F and K are congruent by the alternate interior angles theorem. And then FK is congruent to itself. Now notice how I wrote that. Notice how I'm writing the names of these angles using their corresponding parts. G corresponds to L. F corresponds to K. And then K corresponds to F. So FK and KF, I can say FK is congruent to FK, I can say KF is congruent to KF, that's fine. But I'm saying that this segment is congruent to that segment because that's how they correspond by reflexive POC. And therefore, for the fifth statement, these triangles are congruent. They give you the triangle congruent statement, so you know what parts are supposed to be congruent. We used a pair of sides, a pair of angles, another pair of sides. And that pair of angles was between the pair of congruent sides. All right. Folks, that is it. That is the second lesson of Unit 4. That we have this shortcut, the side angle side postulate and the side postulate, which says that if we have 3 pairs of corresponding sides congruent, then the triangles are congruent. If we have 2 pairs of congruent sides and the included angle congruent, then the triangles are congruent. It saves us from doing 6 steps of work, and we can simply do 3 steps of work.